All right, so as long as we're having fun, let's do another one. This system of equations will solve algebraically. And the first thing we'll do is we'll revisit a technique that we've talked about before called fraction busting. I'd like to get rid of those fractions, and then I'll be able to combine this equation together with this top equation. So if you recall, with fraction busting, what we do is we try to find the least common denominator of all the fractions. And in this case, I believe that's 9. And we'll multiply everything through 1/3 x minus 4/9 y, and then that's equal to 4/3 times 9. Notice we have to multiply both of these terms that will distribute to this guy and to this guy, and then we'll multiply this as well. So 9 times 1/3 gets me 3x. And then 9 times negative 4/9 gets me negative 4y. And then 4/3 times 9 gets me, let's see, the 9 and the 3 cancel, so that gets me 12. Now, I come up with a sort of a strange result here. Actually, I'll call this equation 2 because it is sort of the lower equation here. The strange result is this, is my equation 2 and my equation 1, they're exactly the same as each other. And when I have that sort of thing happen, what we say is that our system is what's known as an identity. In other words, this equation is the same as this equation. When the two equations are the same as each other, it's just one equation is itself. The other one is the same as itself. So that's sort of like an identity. It's our identity. So anyways, that's one way to refer to this. We can call it an identity. Another way that people refer to this is many solutions. So we'll go ahead and we'll add that. Yeah, I'd like you to add that to your notes. Many solutions. And some people refer to this as infinite solutions. But I'm a little nervous about the term infinite solutions. While it is true there are infinite solutions, there are infinite solutions to most of the inequalities that we've looked at already. But one of the reasons that we refer to this as infinite solutions is because when we go to graph the two lines, and I'll show you a little example here, when you go to graph the first line and you go to graph the second line, they're right on top of each other. And I'm not saying that this is the graph of this line. I'm just saying that the two lines will be right on top of each other. So what happens is, just like in the previous example where you are trying to find the solution of the equation, the system of equations, and you're looking for the point where the two lines cross, in this case, the two lines cross at infinitely many points. Now, the reason why I have a problem with calling this infinite solutions is because it doesn't mean that every x, y in the world is a solution to this equation, to either one of these. It just means that the two equations share an infinite number of solutions. But clearly, we could have points over here that have x's and y's, and the value of this x and this y will not be a solution for either of these equations. All we're saying when we say infinite solutions is that for the two lines, any point that's on one line will be on the other, and there's an infinite number of points. Okay, let's try. Oh, one other thing I want you to notice before I'm done here. It's this. If I went and I subtracted one equation from the other, what ends up happening is I get 0 equals 0. And this is another indication that I have infinitely many solutions. Certainly I don't have one solution, and we'll look at another case in a minute, but in this particular example, if I have a number and it equals itself, then we can say infinitely many solutions, just like I said a minute ago. So if this is the result you get, 0 equals 0, or some number equals some number, you can say infinitely many solutions or many solutions.